はい。では、よろしくお願いいたします。Thank you for coming to this session. Today, the topic that I want to talk about is a RhinoScript, using RhinoScript with Python language to do some basic automation, basic batch automations. And if you go to the GitHub page in the link inside a meetup page, you can go to this page and can download the script that I'm going to use today. I am still going to try to write this in Scratch, but if you are lost at some point, you can always come back to here to copy paste stuff. And before getting into the real practice, let me just tell you what I am going to do today. Well, so this session is going to be really basic stuff. So this is for people who have just started using Python with Rhino. Maybe if you haven't used any Python language before, that might be okay as well. So what I want to show you is the basics of RhinoPython first, then also how you can reuse the function that you have created as one Python file, and want to show you some batch automation, basics of batch automations by using RhinoScript to import multiple files into Rhino, then also export multiple files, multiple objects into multiple files using RhinoPython. So if you know, if you have understand what I'm going to do today, then you'll be able to expand the knowledge to do several different kinds of automated stuff, hopefully. So, and that's the point of this session. So let's keep up. And if you have any questions, please, in any way you can ask me, you can interact me with your voice or anything with your, I don't think I can see the chat on real time. So please, if you have any questions, please stop me with your voice. Right. So the requirement that you need to have is just Rhino 6. So if you have it, please open it up like this. And let me, okay. All right, so we're going to write the script from scratch. And if you have opened the Rhino, the first thing I would like you to do is to type a command called edit Python script like this. This will open up the Python text editor like this. And this is where you're going to write the code today. Now, some of you might have used Grasshopper with Python before, but today we're just going to deal with RhinoPython itself. And this RhinoPython itself just works inside Rhino. It doesn't really do anything in Grasshopper, but the code that you have written inside this RhinoPython editor could be transferred into Grasshopper later on. So this is going to be a much more basic than using a Grasshopper Python modules, right? So if you have opened up the editor, the first thing I would like you to do then next is to create some empty folder, and somewhere I have saved a folder called, I have created a folder called RhinoScript on a desktop. So please create some kind of folder, some kind of empty folder in anywhere you want. Then inside, create a new folder called temp. This is where you're going to save the exported file with a Python script. And in the root directly off this folder, this RhinoScript folder, I'm going to save all these script that I'm going to create today, that I'm going to write today. Okay. Everything good? Right. Then let's start. So let me go back to the GitHub page to explain the steps. So there's going to be in total 5 steps. And the first step that I'm going to do is to create a simple object aligned on a grid, and it's going to be a box geometry. So the function itself is pretty simple, doesn't really give you much insight, but what I want to do is here is to create a different kind of shapes on different in each cells on a grid, and then later on I want to export each of them, each of the boxes which has been rotated in different angles into different files. In this case, a 3DM files, the Rhino files. So in first step, I'm going to create a box, this, and then create a grid. Then copy this box into a H grid. But can I just change the way I share the screen? Because, yeah, let me just stop the sharing and let me share the screen by using my camera. And let me change the background. So if you zoom up to my camera screen, I think you should be able to see the camera like this. And by changing this, I think you'll be able to see the desktop. Can you see this? All right.
Yes.
Okay. So I'm going to do like this without doing the sharing. All right. So as I said, I'm going to create a box like this and move the box to each point. And at each point, I'm going to rotate the box with different angle using different axes. So for x-axis, I'm going to rotate the box using a z-axis. For y-axis on a grid, I'm going to rotate the box using maybe an x-axis or something to rotate like this. So keep that as an image and let's try to code that up. All right, let's go back. Okay, so
the resolution is not clear. Maybe the
okay.
because yeah, the screen is your video, and I don't know anyone else can see.
Is anybody else having a same problem with the resolutions?
It's kind of blurry, so I can see the text, but it's not that clear comparing
Okay.
the screen share.
All right. So maybe would it be better going back to the sharing screen, or everybody else seems fine? How's everybody?
Yeah, let's do share screen, not using the video.
All right.
Yeah.
Okay. Like this?
Yeah, that is much better. Thank you.
Okay. All right. So I will try not to use a sketch then. Okay. Then, wait a minute. Let me just go back to this, right? Okay, so the first line you always want to write up when you use a Python script inside of Rhino is this line, import RhinoScript syntax as rs. Now, RhinoScript syntax is an API for Rhino, which you can access to several various kinds of functions that is Rhino dependent. So this is this module is only for Rhino, and this has several functions like adding a point, adding box, asking for selections, and so on. And there's also a bit low-level API called Rhino. This is a Rhino Common SDK. It's a bit different by RhinoScript syntax. A RhinoScript syntax is kind of a utilized scripting language only modules, which depends on this Rhino SDK, Rhino Common SDK. So I think that in most of the cases, it's okay to use this one at the first line, but sometimes if you need more low-level operations, you also need the Rhino Common SDK as well. And in this case, I'm going to use the specific class called geometry, rhino.geometry, in order to create like a vector 3D class or point 3D class later on. And I'm going to rename this as geo. This as rs or as geo means that it's just shortening the name of this long name, RhinoScript syntax and rhino.geometry. So this one and this one just means the same. You can use either one inside the code. Right? So far, so good. If anybody have questions, please throw anything. Right? And maybe throwing the questions on the chat should be also fine. All right. Next, I'm going to also import the module called math. Math contains several functions you can use, like trigonometry, like cosine, sine, and so on. So we'll be using that as well. So let's import that as well. Okay. Now, next thing I would like to do is to create a function like using a def. So def is always used to create a function that can be called later on. So for example, if you have created a def run, def space capital R run, and with the parenthesis, and then use with close with the colon. And if you do the return, you'll have 4 spaces on next line. Then on next line, you can type some functions that you want to run. Now this will be the very basic structure of the functions. And at this point, you want to save the file. Let's save this using Control S or go to the File menu to save. Now I'm going to save the file named as create boxes. Or was it? Yeah, or create just box is fine. I'm going to name this as create box inside the empty folder, which has a temp folder in it that we have just created like this. So check that the file has been created like this. Okay. Now the next thing you want to do is to check if this function runs correctly. At this point, we have just defined the function, but it doesn't really run because we haven't called yet. If we play this script using clicking this play button, nothing will happen because nothing have been run. after you have defined the function, you have to actually call it to use it. So after defining the function, fix the indent and then type run like this, and then click play button again. Okay, I think I need to save this. Okay, I think something has been printed right here. It says 1. So this is the result of this function that has been run. And we have just printed this one. If we type some strings and do the play button again, we could print out the string on the console like this. So is everybody okay with this? All right, hopefully. All right, then, so let's get into more in detail. The first thing we would like to do is to create a grid point, like on the X and Y direction. And to do that, we need to define the number on X direction and number in Y direction. How many points on X, how many points on Y. So let's have that as a parameter inside for this function. So I'm gonna create 2 parameters like this, xnum and ynum. Xnum will be the number of points on X direction, ynum will be the number on Y direction. And let's try to create just the points for now. Okay, so to do that, we're going to use a loop function called for loop. Okay, and in order to create a loop, we're going to write like this. So this is the first loop, for I in range x num. Now, range with the parentheses and inside is x num means that you want to create a series of numbers from 0 to this x num. So if the x num is 3, then the range with 3 will give you a number in between 0, 1, 2, meaning you will be able to get a total 3 numbers from 0 to 3 minus 1. So 0, 1, 2. And in this range 3, 0, 1, 2, in this series of numbers 0, 1, 2, you're going to pick one by one. So the first number will be 0, second number will be 1, and third number will be 2. And each time I is that number. So in first loop iterations, the I will be 0. Second loop, the I will be 1. And this third loop, the I will be 2, and so on. And let's try to create some points at this point. All right, so in order to create the point using RhinoScript, you can use either RhinoScript syntax or Rhino geometry, but using RhinoScript syntax is much easier, so let's use this one. To do that, first you type rs, which is this one, and then type dot. Will give you a list of functions that you can use. And the first function we want to use is a add point function, which is this one. And if you type a first parenthesis inside the console, under the console right here, it will give you some hint what kind of parameters you can use for this function. Now it's a bit too small to see, but if you look at it carefully, you can see that there is 1, 2, 3 parameters, or just 1 parameters. If you want to apply, if you want to use 3 parameters, the first parameter will be x, and second will be y and z. if you just want to use one parameter, and then you can use a point3D class. Now, I think using X, Y, and Z is simpler, so let's use 3 parameter type. Okay, so the X, we can just type, say, 1 or just I, right? And then for Y and Z, I'm just gonna type 0, like this. Okay, now it's just it. Let's try to run this, save this script and run this and see if anything wrong. Okay, I think I have something wrong here. And okay, the problem right here is that since we have just created the parameters for the run, we also need to, in order to call this, you need to type some kind of parameters right here. So we have to provide xnum and ynum. So we have to provide some kind of 2 numbers separated by comma, like this. So it could be any numbers, just use your own numbers and try to run this again. Okay, if you run it, if you look carefully, you'll be able to see the 4 points, in my case, 4 points on a Rhino screen from the center. Okay, is everybody okay? Okay, hopefully, right? Okay, so that's for the X direction. So we could, oops, I didn't need to delete that. So if you want to create for the Y direction as well, then you do another for loop similar to xnum on next line. And then whenever you have a for loop or a define, or later on if you want to use the if conditions, you need to indent with 4 spaces. You can type tab, you can click tab key to create an indent for 4 space. So, and since, and I am using n for the next, the second for loop for the Y direction. So I can just replace the second parameter with n as a Y value, like this. So let's run this again. And here we go. You have 4 points on X direction and 7 points on Y direction. You now have a grid points like this. Perfect. Okay, let's delete this. Now, now we are good to go with the grid points, the grid positions. Next thing we would like to do is to create a box. So on each point. So let's do that. So I am going to comment this out, this rs.addPoint, to cancel these functions for now. To comment out, we use this, how do I call this, characters to comment this out. By having these characters in front of the code, you can cancel the code. You can skip this code to run, right? All right, so let's create a box. So the box can be created using rs.addBox. Okay, now if you look at the parameters, what you have to input as a parameter, it says it's just 1 parameter, but actually this is the list of points like this, and which is 8 points that defines the corner of the box. So that means you have to, if you want to create this kind of box, what you need to have is each corner's point position on the top and the bottom. So in total 1, 2, 3, 4 in the bottom, and 1, 2, 3, 4 on the top. So you can either do like create a point by manually typing the numbers for every 8 points, or you can use a bit more smarter way to apply create the point positions. So let's try to think about the rule. If you just want to create the box which the radius is 1, meaning the size for x, y, and z is equal to 2, then the center of the box is on the 0, 0, 0 position. So think about this box, how we can create it using a code without typing each point coordinate manually. And if you think about that, there is some kind of rules. We can think about some kind of rules here for each point positions. Now, the bottom point and the top point can be divided into a z equal -1 or x z equal +1. And also we need to check the order, what kind of order we have to provide by the point as, and it says counterclockwise order. So that means we have to create, if we want to start the points from here, then if it counterclockwise, then starts here. The first number, if the first point is here, then the second point should be here, and the third point should be right here, and the fourth point should be right here. Then after that, going to the top, and then starts here, 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 here. Okay. To do that, maybe we can divide the process into first bottom and top, and then second we can create some kind of rotational point positions, maybe using trigonometry, like we try to when we try to draw a circle using cosine and sine. So let's do that. Let's try to do that. Okay, so we are going to divide. We're going to create 2 for loop. First for z direction, so which will be the first loop will be for the bottom, the second loop will be for the top. Okay, so for s in range 2, we just need 2 loops. And for the second loop, we'll need to use the counterclockwise rotation, and we need 1, 2, 3, 4. So for the second loop, we need 4t in range 4. This. Right. Now, x, we need to provide x, y, and z in order to create a point for the box. Now, x and y is this flat plane location for points for a box. And then for that, you can calculate that using cosine for x and sine for y. And each step at each t value, which is for the this counterclockwise loop, we can increment this angle inside cosine and sine with 90 degrees. So the first value could be 90 degrees, second value could be 180 degrees, and so on. Then as a result, you'll be able to create a squared shape, possibly. So let's do that. Now, in order to use a cosine, we need to access the cosine function from this math module that we have imported. So first we type math, then do cosine. Then inside the cosine, we need to type the angle, which will be in radians. So, and that we would like to convert degrees into radians later on. So first we're going to multiply 90 by t. So the t starts from 0, so the first value will be 0. And when the t is equal to 1, then this will be 90, and so on. Just increment by 90 degrees. Now, this is in degrees, but we want to convert this into radians, so we are going to use another function from math modules called radians, like this. Okay. Right. And one more step. This function will give you the x value, and maybe we could do the same for the y. Just replace the cosine with sine, and everything else is the same. We can just copy this. Oops. Inside the parenthesis, like this. Now the combination of cosine and sine will give you the point position on the circle. So if you make this angle really small, then you can actually create the circle point. But the problem here is that by using cosine and sine, the radius is always equal to 1. And currently, what we have just calculated is the distance between the center point of this box to a diagonal point right here. But what we have actually done is setting the width, which will be from the center to the edge, to 1. So the diagonal distance is not actually 1, but it actually is a square root of 2. So we have to multiply this by square root, math dot square root of 2, this. And the z is much easier. You just type -1 plus 2 times s. So when the s is equal to 0, which is this loop, then the value will become 1, just 1. When the s is equal to 1, then this equation will give you 1. So you have either -1 or +1 for a z. Now, as a result, you'll be able to get all the points created using these equations, hopefully. Now, let's try to see that by creating a point first. So, and in order to use a add box, you kind of need to supply a point 3D geometry, point 3D class inside this array. So let's create the point 3D. That means that you don't need the actual point geometry. This is the actual point geometry right here. But this is not actually a point 3D class. This is a geometry point. But there is an arbitrary class in order to explain the point position, which is called point 3D. And we need to use this to create a point for x, y, and z for box corners. To do that, we're going to use this one, rhino.geometry. So let's name the point as point, lowercase point, and then equal an access to the geo dot point 3D. So this is the class that we want to create. This is the type of the class that we want to create. Then inside parentheses, we just type x, y, and z. Then you'll be able to create a class that we can use for the box corners. Now, as it says in the rs.add box, we need to provide the array. So let's also create a array for the points, which can contain a multiple number of points. So I'm going to create an empty array first outside the for loop for the box, like this, points equal to empty array. We're using a square bracket like this. And then inside the loop, after we have created a point at each iterations for the loop, I'm going to say points app.append, which will bring this point inside this empty container. And in result, this is a loop 2 by 4. So in result, we have 8 points inside this container. Okay, so far so good. If you have any questions, please let me know. Seems good, hopefully. All right. Okay, now let's see if we got the box. Now we are going to create the box by escaping the loop by deleting 8 spaces, so 2 indent. So the line from this, the starting line for this points equal to empty bracket should be right here, the same here, same line here. Okay, and here I am going to call rs.add box with the points as a parameter. Okay, now let's see if I play this. Let's see what I would got. Okay, did it do anything? Let me play this again. Okay, it has created 4 by 7 boxes in the same place. Okay, but at least we have created the box. Now it is rotated by 45 degrees. That is because we have created the points from 0 degrees. So this is the 0 degrees position. This is 90 degrees position. So if we want to rotate this so that this box will align with the XY axis, you just need to add this angle by 45. Like this. So I have just added by 45 as a starting point of the angle, right? And as a result, you'll be able to, first I'm going to delete this. And if I play it again, you'll be able to have a XY aligned boxes. Now it's time to move the box in X and Y direction and possibly rotate it as well. We could do the rotation first, because first we want to rotate the box on the center position. Then after that, it's much easier to transfer it. If we do the rotation after the transferring, we need to define the center axis for each box after we have moved it. So it's a bit complex. It's going to be a bit complex. So rotating first, then translating is easier, I think. So let's do the rotation. And also we're going to create the, oops, we didn't need to. We're going to create the empty array, which will contain all the boxes that we have created right here, so that we can reuse this later on. So I'm going to create an empty boxes array right before going to the first loop right here. And I'm going to store this add box result inside the variable called box. Then, like we did for the points, I'm going to add the box inside the boxes so that we can use it later on, right? Now, let's try to rotate this using another RhinoScript function. Now, in order to rotate it, I'm going to first update the box by saying box equal, then call a RhinoScript function called rotate object. Inside the Rhino object, rotate object functions, what you need to type is the ID of the object, which is equivalent to this box that we have just got, then the center point, which could be 0, 0, 0 position, and then rotation angle, which can be calculated using I or N. Then finally axis, so the rotation axis. I think the default value is z-axis, but we want to change the axis dependent on if we are going to rotate on the x using I or using N, right? So, so what I want to do is to do a two rotation operation. First for z-axis, and then using I value right here. And then for the second rotation, we want to rotate using x-axis using N value as a rotational angle. So let's do that. Okay, so the first parameter is this box that we want to rotate. And the second parameter is the center point. So we can create a 0, 0, 0 point 3D positions like we did right here. And the third one is the angle. For the angle, I would like to create angle between 0 to 90 degrees based on the number of xnum. So that means the total number will be 90. And I'm going to divide this by a x number minus 1. So if the x number is equal to 3, then this will become 2. Then if we divide that if we divide 90 with 2, then we get 45 as a value. And then I am going to multiply it by I. And I is in between. If x number is 3, then I will be 0, 1, 2. So as a result, you'll get 0, 45, and 90 degrees as a result for this one. Now the RS rotate object asks you to use an angle in degrees. So we don't need to convert this into radians. So we can just keep the angle like this. Now's the time to set the axis. The axis can be provided using another class, which is called vector 3D. And that can also be accessed from this geo rhino.geometry SDK. So geo dot z vector 3D dot z axis. Right. And we can just copy this, paste it. And what we need to do is just to change I with N, and then z-axis with x-axis. And this should give you two rotations, both for grid cells on x direction and grid cells on y direction with different axes and with different angles. If we play this, you see that several types of rotation has been done on one places. Now it's not been moved yet, so it is on the center, still on the center, but we see some rotation right here. Okay, anybody has some problem here? Is everybody okay with this? Let me know if you have any questions if you haven't done it yet. Seems okay, probably, right? Okay, now it's time to actually move this into a XY direction. And that is...
I have a question for
yes.
The rotation second one.
Yes.
It's x num minus 1 or
oh yes, I need to change this to y, sorry. Yes, you need to change this to y num. since we're just using this n value. Thank you for pointing that out. All right. So next thing, I'm going to use a function called rs.move object in order to move the box into a grid points. So what we want to move is the box, and for the second value we need to we need to use a vector class which determines the direction or the position where we want to move the points, the box to. And for that, we can first access to a vector 3D class like this. And inside the vector 3D, we can provide X, Y, and Z value, which is the actual position for the grid cells, for each grid cells. And as we did for points, the X value can be used with the value I, the Y value can be calculated with the value N, the Z can be just 0. So if we do I and 0 and play it, maybe that's too close. Yeah, that was too close. So we need to have some margins in between the boxes. So we can multiply I by something like 4 and by 4 as well. And then let's play that again. Okay, now it seems to give you a better result. Right, so now we have just created a box. We can leave this function as it is and go to the next step. Now, before doing that, we might have noticed that when we run the script, the box seems to create it one by one slowly. So if we try to create like 1,000 of objects, it's going to be really slow. So in order to prevent that, we can skip each time drawing and just do the calculation within the Rhino and just draw the result right after all the calculation has been done. So to do that, we can call, before doing anything, we can call rs.enable redraw, and inside the parameter we say false. This will, by using this, you can disable the drawing process, which will be done afterwards. Then after we have created all the boxes and put the boxes inside the boxes array, then we can escape, or we can leave the loop by going to the first indent, which is this one. So check the correct indent position, then say rs.enable redraw true. And by writing this to set of code, you'll be able to get the result faster. Okay. Right. And finally, I'm going to return the boxes that I have created right here. By using a term return like this, but you'll be able to get a list of boxes from this function. So you can currently, without any return, this run doesn't give you any, this run isn't an object, it's just the none type. But if you do a return, and do the print again, this is actually a list of objects, which is equivalent to these boxes that you have returned. So this function itself becomes the object. So you can type something like this and reuse it as a list of objects. Now this is pretty important, so please remember that. And make sure that this runs okay in your environment, and I am going to comment this out since later on I am going to import this script from another script. And when we do that, we don't want to run this testing code right here. This is just a testing code. Okay, so far so good. Anyone has any problem with this? Yeah, I do hear some weird white noise. Everything okay? All right. So let's get to the next step. Next, we're going to create a function in order to export an object. So let's create a new script. Then save this as, let's say, export objects, export object. So I am hearing some. Okay, looks fine. All right, so let's do this. So next thing I would like to do, I would like to create a script in order to export the object that have been selected. So let's do the same magic word, import RhinoScript syntax as rs. This is always necessary. And do the create the basic function like this. And this is to test out the function that we have created. Right. Okay, so the next thing we would like to do is to say we have several objects like these, and we want to export it like we do from the export command in Rhino with any file type you define, like could be SVG, could be STL, could be 3DM. So we want to create some that kind of functions using RhinoScript. And to do that, unfortunately, there is no export function inside RhinoScript syntax. So to do that, we need to kind of access to this command line like we are typing right now. And we can actually access to this command line using RhinoScript. So I'm going to show you how you can do that. Right, so to do that, first of all, as a parameter, I'm going to type an object that you want to actually export. So I'm going to call it objs, which is going to be the array of object that you want to export. Then you, in order to export the file, what you need to provide is a place where you're going to save the file to. So in this case, you need to provide a directory, which is equivalent to this line right here, and also a extension, the type of file. So let's provide two more parameters, directly and extension. And this will going to be a string value. Right, so we have 3 different parameters, and now what we want to do is to first access to each of the object inside the object array. So we can do that by using obj and objs loop. By writing like this, you can access to each object inside this array and name each object as RBJ in this case. You can rename this into any name, could be just O. Right. Right, now next thing, or the other way around, you can also say for I in range length of objs and obj equal to objs I. This is pretty much the same thing that I'm doing. The only difference is that I'm using the length of this object to make a series of numbers and using I as an iterative numbers, and using that I value to access to each object like this. In this way, you can also use I for other purposes. So in some cases, this is better. And I think I'm going to do in this way. All right. Now, first thing we need to do is to create a file path. Now we already have the directly from the parameter, which is right here. But we need to also define the name of the file that is going to be exported. And also we need to combine that with the extension. So first we have the directly, and then we can add a string, which is going to be the name of the exported file. In this case, a / exported. And since we're going to export multiple files, each file should have different names. So for different names, we can reuse this I as a concatenated string. So we can add exported plus the number. So the first object will be exported 0, the second object will be exported 1, and so on. Then finally, we can add an extension like this. Now the extension script itself could contain dot, or if not, then you use dot plus ext like this. So this will be the file path that you want to save the file as, directly plus the name of the file. Now's the time to access to this export command. Now in order to do that, when we do the export command, we actually need to select the object. So first thing we need to do is to actually select each object. And the one that we want to select is this obj that we have just got from the array. So first we need to select the object using rs.select object. Like this, right? Now after we have selected, we can call a RhinoScript function called command. And inside this command, we can actually type this export command right here. Now, this is going to be a list of string, and when you try to call the function, when you try to call the command using a script, it's better you always use this way. First, this character, then underscore, then dash. So remember those 3 characters. Then export. Right. Now after this, you also need to define the file paths right here. But before getting into it, let's test this out if this really runs. Okay, so inside this run function, we need to enter like the object ID and the directory and the extension. So to do that, let's try to give a questionnaire. Let's try to give a asking command right here, like how many, where's the file position that you want to save, or like how many objects you want to create and so on. Okay, so for the first parameter, it's going to be object, and we can actually create a boxes that we have just created using createBox. So let's try to import this createBox script inside this export object script and reuse this to actually create a boxes list of boxes. To do that, we can type import. If the important thing is that all the script that you have written should be inside the same folder, and that is really necessary in order to use the technique that I'm going to show you. Keep in mind that all the script that you have written is inside the same folder, and then if you say import and type create, you'll be able to see the script you have written by yourself as a module. So import that. Then after you have imported, you can access to the function that you have created inside this createBox Python script. So in this case, you have a function called run inside the createBox. So you can say create box dot run and then type a number of values, number of boxes you want to create on X and Y direction. And let's try this out. Let's cancel this, comment this out for now. Let's see if this works. Okay, if I play it, yeah, I think I've got the 4x4 boxes. Now, let's see if everybody got the same result. Is everybody okay with this? Let me know. All right, okay. And as we have done it right here, as we have done the return boxes right here on the end of the run function inside the create box, we can actually use this, store this in the array, like inside the boxes like this. And this boxes will actually be the array of object which can be imported in, which can be inserted inside this run function for the export script. Right, so we can type like this. Okay, for the second parameter, we need to type it directly. Now we can either type it manually by going to, say, temp folder and copy the value right here and say paste it like this, or you can also create a asking command, ask user to define where the folder you want to save. And I'm going to do it that way. So temporarily, I'm going to name it as direction and also extension as well. Maybe for the extension, I'm just going to make a constant value like 3dm to make it easy. All right. So how can you ask a person to define the folder? You can use another RhinoScript syntax, which is called rs.browse for folder. All right. And if you look at the parameter, it says you have to define 3 parameters, which is all optional. One is default folder directly, one is the message, and one is the title. I'm just going to define the message. So the first parameter, I don't want to set any default folder, so I'm just going to type none. Then for the second parameter, I'm going to say select folder to save files. Could be any name. And for the third one, title could be just none, so I'm just going to skip it since this is optional. Right. So let's see if this works. Okay, so let's run this. Now, if the code has successfully has been run, then the browsing window should open asking select folder to save file, right? If this shows up, I'm going to open up the temp folder, then just select. And the new command line has been appeared saying save file name. So the problem here is that inside the rs.command function, we haven't really defined the folder path yet. So it is actually asking where to save the file when we have used the export function. So we need to actually do that. I'm just type escape to escape all the functions. Okay, so we did browse to the directory that we want to save, that we haven't actually used this for this command. So let's use that. We already have it directly, and we have created the file path from the directly inside this function. So after the export, in order to specify where to save it, we say first we create a space after the export, then append a string, which is this file path. Now the file paths sometimes have space inside, and having a space using a command is a bit of problem. So we need to use a double quotation in order to make this as within the string. So currently we are already using double quotation like this in order to define that this is a string, but inside a string we also need to provide a double quotation. So to do that, we need to escape the double quotation using a backslash. So let's do that. And to do that, we can type maybe after the export, writing space, then type backslash, then type another double quotation. So the combination of backslash and double quotation will make this itself a string inside this double quotation. So this one and this one is a bit different. This is the string that can be used inside double quotation. All right. And we want to close this with another double quotation. So I'm going to copy this and add. So I'm going to create another string, and inside this, I'm going to copy this one. So it looks a bit confusing, but this is one, consider that this is one character, and that this is used to close this file path, right? And after this, you can then type maybe have space after this, then say enter maybe second time. The reason why I'm typing to enter is because sometimes you need to skip additional options, like if you want to export it for a mesh and so on. So I'm going to, and this is equivalent to when I type enter in command line like this, right? Okay. All right, and after we have exported the object using our rs command, we want to, no. We want to unselect all the object because the command always works for select our object. So at each loop, we want to have single object being selected. So at each end of the for loop, we want to unselect all object using rs.unselect all objects. Right. And same for this one, we can use also the enable redraw to make it faster. Yes. Right, let's try this out. Play it and asking where to save. Select the folder that you want to save. Maybe for me, this temp folder. Select it. And I have error. Right, the problem is, okay, I think I need to set this as a string as well. Right, sorry for that. So should be written like this. Should be closed with this double quotation, this entry as well. Okay, my mistake. Let's try this again. And I am going to delete this. Oops. And start this. Select the folder and something is happening. And if you go to the temp folder, voila, you have single object, each box objects being exported to different files. I hope. Let's open one of the file and see if that's true. Yep. Like this. So is everybody okay for now at this point? Everybody have successfully exported the object. All right. Thanks you. Now, let's comment this out. Oops. You can comment this out by selecting the lines and then say control / All right, and save this. I have just commented this out since this is a prototype code in order to test out the function that we have created right here. All right. Now, next thing we want to do is to create a importing function. And that is a bit similar to the export. So I'm going to duplicate the script that we have created right here. So go into the file menu and I'm going to say save as. Right. And then name this as import obj. Import objs. Now, I'm going to do the stuff by imagining that you have already exported some of the objects like this inside a temp folder or any folder that you have selected. And what I'm going to do next is to import all the objects that you have exported into the temp folder. So I'm going to delete the object that had been created on the Rhino display. Right. Now let's try to create an import. To do that, what you need to do is to first find out the list up all the objects inside a specific folder with the specific extension, right? Okay, so since we're not going to create any boxes, we can delete the create box import module. We just leave with RhinoScript syntax. Instead, we're going to import another module called OS. Import OS. OS is not Rhino dependent. It is, you can use it in any Python environment. This is used in order to like create some, for example, create directly, find out a list of objects inside a specific folder and so on. And we're going to use this. Okay, and inside for the define, we don't need to specify any objects because we're just importing it. So just delete the first parameter and leave direction and extension. Directly and extension. All right. Now, say that we already have defined the directly when we use the run function. So what we want to do next is to check how many files are there, or how many files are there that we would like to import inside that folder, inside this folder. So first, and store that inside, say inside this file, empty array. When we have found anything that we can use, right? So first, we could list up all the files using an OS function, OS modules, and that can be done using os.list directly, like this. This will give you a list of name of the files inside a specific folder. So say this, if you have said that direction is this directly, you'll get the name of each files inside this folder. But same time, this will also give you another type of files other than 3DM files, like text file as well. But in this case, we just want to import only the 3DM files, which is defined by this ext. So we need to skip those txt files somehow. So to do that, we're going to loop through all the file name inside this list. Then we're going to check the end of the file name if it ends with this ext or not. So we'll create a condition called using if. So if file dot, and there's a function called ends with, which doesn't show up in this hint but should work. So if file dot end with and dot plus ext is true, so this condition will run. The one that's inside after this if condition, for example, this print, will only run when the file that you have found out, that you have checked, have an extension with dot extension value that you have specified in parameter. So if this is equal to 3dm, then only the 3dm file, when only the 3dm file has been found, this code will run. So in that case, I'm going to append the correct directly in order to access to that file by adding directly plus slash plus actual file name. So as a result, when you escape, when you leave, all the code has been done after this for loop. All the files with a 3DM extension and all that file path is going to be stored inside this files array as a string array. Okay, and after this, you can access to each of the file paths and import one by one using another command called import. This one. So when you type import, it will ask you to select the file that you want to import. Then if you say okay, you can import the file like this. So, and to do that, we can use this rs command again. Now, inside this, after this enable redraw, we don't need, we don't already have the obj.js array, but instead we have this files array. So rename this obj as with files, then rename obj with file and files like this. So at each iteration in the loop, we are accessing to the directly we want to access. And we don't need this as well. Maybe we can name it as file path since we're using it right here. And we don't need to select the object as well because we're not importing it, we're not exporting it. And instead of export, we can rename this to import like this. And we don't need to unselect all objects, I think. Maybe after we have imported all of the object, we can unselect all objects. And this could go to the last. Like this, right? And let's see if this works. Okay. Now, to define the directly, we can reuse this directly equal rs browser folder, maybe select your folder to import files. And then run the script without boxes and only the 3DM files. All right. Like this, and let's try to run this if we can import the files in batch. Now the place where I have saved the STM files is inside this RhinoScript and temp. So let me select this folder, which you can find all those 3DM files that have been exported. Okay, now if I select it, something happens, and yes, all the files that have been exported has been imported back again. Okay, everybody, so far so good. Anybody has any questions so far or have any problem, let me know. Should I stop or should I continue? Okay, hopefully you're all good. Right, now, next thing I would like to do for the import object, after we have imported object, actually we want to store that as a list of objects again. So after we have imported all of the object, I want to, when we run the function, I want to actually return it as an object, like we did for the create box, like here. So to do that, we need to get the actual object stored inside the array. like the boxes. So let's think about how we can do that. To do that, first we can create a empty array, like imported objects, like this. And inside this imported object, I want to store one by one the one that has been imported after using this command import. Okay, so to do that, let's try to import just one object inside the temp folder and see what's the characteristic of this object. And the characteristic is that after we have imported one object, the object is going to appear on the Rhino display with object being selected like this. So what we need to do is to retrieve the object ID which has been selected inside a Rhino display. And there is just a command for that. So first we can create a variable like selected objects and say rs.selected objects. And this function will give you the object ID of selected object inside a Rhino. And as a result, you'll be able to get a list of a object ID like this. So you cannot just do imported objs append, since imported objs is a list itself, and the result of selected objects is also a list. So when you add a list inside a list, you're just creating a double list or multi-dimensional list, and that is not what you want. What you want is making all the objects being stored in flat array. So instead of using append, I am going to use extend in order to merge those two arrays together. In this way, you can just pick up all the objects inside this array, then store it inside its imported objects. That's one of the essential function for Python. All right. And finally, you can return that imported objects. And let's see if we got the result by checking the number of objects like this. Okay, so I'm printing the number of arrays which is going to be created using this run script, which is this run function here. Okay, let's test this out. I'm going to delete this and run this again. Select the folder you want to import. And as a result, it says 16. So I have successfully imported 16 object and successfully created a object array, which contains 16 objects. Great. Okay, so far so good. Everybody looks fine, hopefully. I'm gonna comment this out again. All right. Right. So we have now created the essential, I mean, in this session, essential script, essential functions in three different files. One is to create a box, one is to export the objects, and one is to import the objects. Now's the time to combine all those scripts together to do some batch automation. The first batch automation we want to do is to first create a box, then export that object with a specified file type. Maybe last time we exported it using a 3DM type, but let's try to export it in OBJ file type. Right, so to do that, I am going to make sure that you have comment this out, comment the last part out, outside the run function, and save it. I'm going to create a new script. And for the new script, I'm going to name it as, say, run export boxes. Okay. Now, first of all, we want to create a boxes. So, but first of all, we can always do like this, import RhinoScript syntax as rs. Then to create a box, we have created our own function inside a create box module Python script. So import that. So if we want to export the object, we could also import this export RBJS script like this. Now we are able to access to both create box and export RBJS functions at the same time. And that is the purpose of this session. We want to first create a module by yourself, which can be reused every time you want to use it. Then at each time you want to create a batch operations, you can re-import that as a function, then use it combined with other small modules together to do your special cases, case functions, create a special case functions. Right. Okay, so when you create a box, you need to specify the number for X and Y. So for that, let's create some, let's let command line to ask you how many numbers you want for X, how many numbers you want for Y, right? So xnum equal to rs get integer. Rs, okay, I don't have any hint anymore. Is that okay? X number equal to rs dot, okay. So there is a function called get integer. When you have a name get right after the rs dot, then that always means that it lets you ask inside the command line. Sometimes it could be a asking for numbers, something asking for strings, sometimes asking for layers and so on. So remember, whenever you want to create your command line UI, look for a get. Okay, and in this case, I want to ask you to type an integer value. And the first integer value that we want to create is for the X, the box number in X direction. And the parameter you have to input is message, a default number, a minimum, and a maximum. All right. So let's just say the message will be just X number. In my case, could be anything. The default number, I'm going to set it as 5. And the minimum number should be 1 in this case. And the maximum, I don't need to set any maximum, so I'm going to set it as 1. All right. Right, then I'm going to copy this and paste it and rename this to ynum. And for this, y number, everything else is the same. All right, so let's check this out by running it, save this and run this. And it will give you a questionnaire saying X number, the message that I have typed, and with the default number 5. If I leave it with enter, it will just give you the file. If you retype it with other values, the X value will be 4, replaced to 4. And if I just enter, then the y value will be 5. And all those values will be stored inside this variable. Then we can call the create box dot run, which have two parameters, xnum and ynum. So we can type like this. All right, and let's run this again. Asking for numbers, say I want the x number to be 4, y number to be 6. And as a result, you'll be able to get 4 by 6 boxes. Right. So far, so good. Okay. Now we are already having this boxes as an object ID inside as a list of objects. So what we can do next is to save these boxes into a specific folder. So let's create another browse for a folder function, rs.browse for folder. The default folder, I'm gonna say it none. Then asking select folder to save files. Right. And also maybe if you want to specify the extension as well, then maybe you can also say get string. And then for the get string, you have message default string and so on. So maybe type x file extension to save. And then default could be 3dm or maybe obj. And let's keep it like this. And finally, you can call this export obj.js. Export obj.js dot run. And for this one, you need to specify, you need to type 3 parameters, list of objects, directory, and extensions. The list of object is equivalent to this boxes. So copy this right here. And the directly is this one right here. And the extension is this one right here. All right, so let's try this. Run it. So first asking for number of boxes. Let's say X number is 5, Y number is 7. And after that, it will ask you to select the folder to save files. So I'm going to select this temp folder. Now next, it will ask you the type file extension to save. The default is obj, so I'm just gonna leave it as it is. Enter, then wait for a moment, wait for it. Okay, I have made too many files. And voila, I have in total 35 obj file exported. All right, let's check this out. I'm going to import this one of the object. And where is that? Okay, right here. Successfully has been imported. Okay, so this is it for creating the box and exporting. Now also, let's also try to do the importing part as well, combining several stuff together. Now, for the importing practice, I'm going to leave the object like this. So keep the object like this for now without deleting it and create a new file, new script. And for this one, I am going to name this as run convert imported obj.js. Oops, not here. I have to save it. Right. Run convert imported objs. Well, it could be any name. Right. And then I am going to type import another modules that we're going to use. At all time, I'm going to import RhinoScript syntax as rs. And this time I'm going to, what I would like to do is to first import a 3DM file. Then after we have imported the 3DM file, I want to convert it into a mesh file, then export it into, say, OBJ or STL or something like that. So this will going to be the conversion testing. So I am going to delete all the files inside the temp folder except for 3DM, just to make sure, just to make it clear what we are seeing. Okay, so we only have 3DM files inside temp folder. You could still contain any other files, but just to make sure that it looks clear what is happening right here. Okay, now next module you want to import is import objs that you have created. Also a export objs. All right, so first of all, we're going to specify the directly where are you going to search for in order to import the 3DM objects. So rs, okay, I am missing the hint. Well, I'm just gonna go like this, rs.browse for folder. Then the first parameter should be none. The second parameter is the message. So select folder to import 3DM files. Okay. Like this, and then I'm going to store all the imported objects using import objs.run. And what was the parameter for run? It was two parameters. One is the directly and one is the extension. So in this case, I'm going to import, I would like to import the 3DM files. Okay. Now, next thing I would like to export the one that I have imported. So let's say I want to export it into maybe some specified file type. So I'm going to add another asking questions, xt equal rs get string. The message will be an extension to convert to, then the default, let's say SDL. Okay, now I'm going to call export objs.run. And for there should be 3 parameters when we want to use the export object. One is the object export, which is this one that has just been imported using import objs. And the second one is the directly. So I'm going to save the file into the same directly where I have imported the 3DM. Now the third one is the ext, which you're going to specify by yourself right here with this question. And finally, after you have imported the object, you can delete the objects so that nothing will kept inside the Rhino's display. I am just going to delete this object as well, since I'm going to just import it. I don't need any object inside Rhino. Okay, so hopefully this works. Let's see. Let's review this again. So first, we're going to call the browse for folder message in order to let you choose directly to import, also to save at. Also, next get string, it will ask you to choose the file extension name to convert to. So it could be STL, OBJ, or any kind of object that can be used in Rhino. Then first import the 3DM object using import objects function. After that, and also stored inside OBJS array. And after that, I'm going to export this OBJS array into a same folder, but with different extension that you specified right here. And after all these done, you are going to delete the object inside Rhino and see if this works. Okay, let's run this. Okay, some errors. Browse. Message modules, object has no attribute. Okay, I think I have done something wrong here. Am I getting, let's see. Let me try this again. If I play it, okay. Module this. Let me comment this out, or let me cut this from here. rs.browse folder, paste it, run it. Okay, I don't know what was wrong. All right, so this is the temp folder is the file that the folder is that I want to import all the 3DM files. Selected. Okay, now it will ask you what kind of extension to convert to. Now let's try with STL is fine. And if everything is done, the object has been deleted. And if you go back to the folder, all the SDM file has been converted into STN. Yes, the batch automation has been successfully done. And hopefully this XDL file right here and this exported 3DM file is at the same position, but with a different type of object. STL is being converted into mesh. The original one is a nerves surface. All right, so this was it. This is it. This is the very basics of a batch automation using RhinoScript. And today I just showed you how you can create your own modules using simple functions by splitting the functions into different script. Then reuse that in different script by importing it as a module. And by combining it together, you can create this kind of batch operations. If you have multiple folders, maybe you can add another for loop inside right here and choose for multiple folders and so on. So the possibility is really vast. You can do a lot with this technique, I think. So that's it. This is it.
Okay, thank you very much for the very useful session. It was great. And maybe it's a time, 5 minutes. We have until 8 p.m. So let's introduce yourself, and maybe in Japanese, you can introduce each other and